Hey, boys and girls, it's been a while since I did this video because I know many of you guys wasn't really feeling it, and now I've been asked to do it, so I'll do this for those who will care to listen. But however, this is a little secret. For those who are paying attention to this video, you're going to be well prepared for this test. Your study guide is going to be at least 30% of your test, at least. It could be more than 30, but it could be at least 30%. Knowing Mr. Howard's going to be 50% knowing him. So you could at least get to a 50. And you do a little bit extra work, you could get to a 70, at least that. All right, let's go ahead and get started on this. Question one. You should be able to know these kind of questions off the bat. Most likely, I probably wouldn't put those on the test because probably I would. I would put at least one or two of them. I won't put all three. All right. What are unique characteristics of rational functions? Y'all know the answers. This is my favorite word that you heard me use for a lot. Asymptote. Yes, my Algebra 2 students, you're gonna be hearing about that also more so in pre-calculus. All right. Number two, when dealing with the rational function, what can never happen? Your denominator can't equal 0. Or you could rewrite this as P over Q. Q cannot equal 0. That's the same thing as the statement of denominator cannot equal 0. So you could use either or statement. Describe the rules for a horizontal asymptote. How would you find it? Well, when you got exponents being the same, well, you just divide coefficients. When you have something like this, what the exponent m is greater than n, you have no horizontal asymptote. It doesn't exist. But you have in this case n less than m, being that m is bigger, your HA or horizontal asymptote is 0. So those are the three rules we just did. One, don't forget, same exponents, you divide the leading coefficients. When you have a numerator bigger than the denominator, you don't have a horizontal asymptote. But when the denominator is bigger than the numerator in terms of the exponents, of course, your horizontal asymptote will be 0. All right. Now, most certainly, you're probably going to see something like this on your test. So you got to give me the HA. What's my HA? Well, you got to give me the equation. So let's do like we did before. Let's start with the horizontal asymptote. And I'm sorry that this is a little blurry, so let me relabel these axes so you can see them. 2, 4, 6, 8. 2, 4, 6, 8, 10, 12. Therefore, you can see what's up. Now let's go ahead and talk about the horizontal asymptote. Because the horizontal asymptote in this case is going to be right here. So the horizontal asymptote, remember what it is. If you draw a line through it, it cannot touch the graph. So let's see if it's 1 and 8. If I draw a line through it, 8 won't work. So no 8. What about 6? If I was to draw a line through 6? Nope. 6 doesn't work. What about 4? Well, guess what? It gets close to 4, but it doesn't touch us at 4. It gets very close to it, but never touches it. So 4 works. Let's see about 2. If I draw a line at 2, guess what? 2 don't work. So because it's a positive, because it's 4, guess what? And it's positive, guess what? It stays right there. And remember, your horizontal asymptote stays the same. The signs never changes. All right? Please don't make the mistake. So let's deal with the vertical asymptote. Draw my vertical lines. Again, when I draw my vertical line, my line cannot touch the graph. So if I draw a line at 2, 2 doesn't work because it does touch the graph. But what about 4? 4 doesn't work. What about 6? We got a lucky number because it gets close to 6, but never touches 6. But can we say when we create a function, let's pause it for a second. I know we want to say x plus 6 as the vertical asymptote, but no, 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 no. You can't say that because again, going back to what you know about transformations, remember the vertical asymptote is telling us about h. So because when we look at the graph, it's positive, that means that h is essentially negative. All right? Don't forget about that in the bottom. It does that. The vertical asymptote is just a weird thing that by now you should already accept it, make your peace with it, and dealt with it. So remember, just because when I'm looking at my graph, the vertical asymptote is positive 6, but when I create my function, it's going to be the opposite of it. Do not forget because that's telling us also when we look at the graph tells us pretty much the solution of it. Because remember, when you say x minus 6 equals 0, well, when you solve it, it's going to be x equals 6, which we know x cannot equal 6. So also think of it in terms of the graph. I can't have positive 6 because if I put positive 6 there, it'd be undefined. So look at it like that. All right, find the vertical, horizontal, domain, and range restriction. This is easy. Now, let me ask you a quick question. In the whole time that I've been teaching this unit, have you ever saw me work anything in the numerator? No. So guess what? Don't you dare. Don't you dare. I would jump out the screen and I will cry if I see y'all do this on the test. Don't make me do it. I don't want to cry. All right, let's get started. Yeah, what about the vertical asymptote? Remember, the vertical asymptote is where it cannot be because of the domain restriction, meaning that if it happens, it becomes undefined. So let's look at A. Well, we know that the VA of this, x cannot equals -1, but there is my VA. My vertical asymptote is -1, and because my VA tells me it's -1, that's where my domain cannot be. The domain cannot equal -1. Or you could say x gotta be greater than -1, but I prefer this statement for the domain. And don't forget, vertical asymptote tells me about my domain. Vertical asymptote tells me about my domain. So what about my range? Well, what about my horizontal asymptote? Well, my HA is -3. Now, Don't make this mistake. And when I say R for range, you say positive 3. No, 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 no. The horizontal asymptote is not one of those things that it becomes different at all. But in all our honesty, though, many of us mathematicians really don't deal with the horizontal asymptote don't deal with the range like that. We come to the horizontal asymptote, so you could still say X, or in this case, Y cannot equals -3. You can say that. That's fine. It's not important, but that's fine. The domain, like I said, well, the VA is -1. The domain, X cannot equals -1. Don't pay attention to this negative sign because that's nothing to us in terms of the domain range, all that, and the third. All right, B. The vertical asymptote here is -8. The domain X cannot equals -8. Ranges, well, the HA is 2, or Y cannot equals 2. Okay? And again, on the test, I won't be asking you about range restriction. So I won't ask that, so you don't have to worry about that. We'll be asking you for vertical, horizontal asymptote, and domain restriction. All right, let's do the third one. So the vertical asymptote, -6. The domain, R cannot equals -6 because otherwise it becomes undefined. The HA, -3, +9, sorry. And then the R still could be Y. Y cannot equals 9. And again, I'm not too much worried about range. So what about D? D is a good one. They give me some ideas about your test. So when we come to vertical asymptote, it's going to be, let's look at the denominator. So 2x minus 12 equals 0. Solve it like an equation. Put 12 to both sides, 12 here. 2x equals 12. Divide by that, x equals 6. So essentially, x cannot equal 6 here because if it does, it becomes undefined. So that means that my VA is 6, and my about all that cannot equal 6. HA is 6. R being the range, Y cannot equal 6. Easy going. Again, if you're missing anything or don't understand something, please rewind the video. Because I guarantee you, when you rewind the video, you're going to get what you need. All right? All right, let's look at this. Guess what? In A, since I got no exponent, no x in the numerator, or a number outside of here, I have no HA, no horizontal asymptote. But in B, let's look at it. I do. I have variables in the numerator and the denominator. And because when you look at x is understood to be x to the first power. They both have the exponent of 1, so there's going to be x. So your answer should be, well, is negative 1/4 as your HA. That's what you have for B. Again, following those rules. So what if I have something that looks like this? Well, guess what? Since it's not in the front, I have to look at the back. And in this case, it's going to be a positive third from a horizontal asymptote. So you just got to keep those simplistic things in mind. If you understand those rules, they're going to work out. So again, so far we looked at 2. Well, A was a unique case because it didn't have a variable at the numerator or a number in the back either. So when you see that, you can always just jump to your conclusion. No HA. All right, here, again, following those same rules. So here, you top your exponent in the numerator is heavy. Then it's in the denominator. So guess what? Ain't none. What about here? In D. It's the same thing. None. Don't even factor. You don't need to do none of that. It's not even necessary. All right. Now you're going to find holes, domain restriction, and horizontal asymptote. And yes, guys know Miss Howard. You know that Miss Howard loves a good swing method. So guess what you're going to do in the numerator? Mr. Howard swing method. Well, believe it or not, you don't even have to do swing method on this one. Guess what? They have a greatest common factor of what? You see the 2 out in front, 10, and 12. What is the greatest common factor of those 3 numbers? 2. So guess what? You don't have to do the swing method. You can if you want to, but it's going to be a bit unnecessary. So pull out the 2, and you have x squared plus 5x plus 6 here. And then you have just x squared plus 3x plus 2. Well, it'd be best for you to do all your factoring first. So if you do have holes or point of discontinuity, you could remove those, and then you could talk about domain restriction and horizontal asymptote. And if you wanted to, you could also talk about the vertical asymptote in these cases. So let's go ahead and get the factoring of this. So in the numerator, I have x plus 2, x plus 3 when I factor it out. And of course, that 2 is going to be on the outside. And then in the denominator, I have x plus 1 and x plus 2. All right, let's go ahead and get started with all this. What do I have that I could cancel out? Well, I have an x plus 2. So my whole of this, before you could get to the answer, you got to solve it. Solve for x. And you know that it's going to be negative 2. So x equals negative 2. And that is my whole, or my point of discontinuity. So that's my whole. All right. What am I left with? I am left with the 2, comma x plus 3 over x plus 1. All right. So guess what? What are we left with? Well, we already did it. We already found the whole. Now we could talk about the domain restriction. The domain restriction, remember you think about what number makes that denominator undefined. It becomes undefined at when x cannot equals -1. X cannot equal -1 because if it does, it becomes undefined. And you can also tie that into your VA, your vertical asymptote, to be -1. Now, of course, to find your horizontal asymptote at this point, you, they do have the same variable with the same exponent. So what you want to do, of course, you don't have to do this, but I prefer it makes work easy. 2x plus 6 over x plus 1, because that's what I got. Now, getting back to this. So since they have the same variable with the same exponent, that's gone. So I have 2 over 1, and my horizontal asymptote in this case, because I can simplify 2 over 1 to be just 2. So there we go. We did we found the whole to be -2. We found the domain restriction to be -1. We found the vertical asymptote to be -1, and we found the horizontal asymptote to be 2. And that is how you do part A of 7. All right, I'm gonna do B on the same thing, but I'm gonna erase all this. So if you need more time with this, I encourage you to go rewind and go back. All right, let's do B of this. X squared plus x minus 6 over -4x minus 16x minus 12. Well, let's start out the denominator first. So again, you don't have to do the swing method, because if you do the swing method in this case, your number's going to be too big and it's going to be unnecessary to do all of that factoring. So let's go ahead and get to work off it. So guess what? So we could pull out a -4 out of there, and they're going to be x squared plus 4x plus 6. Well, not 6, I'm sorry, plus 3. And the reason why I write like this, because when you distribute -4 times x squared, you're going to get -4x squared, which is here. And then -4 times 4 is the -16. And don't forget, because I have the x. So -4 times the power of 3 is -12. So that's how you get that. Now, we can finally factor some stuff out. Let's go ahead and do this. So when I factor this, x plus, well, it should be x minus 2. I lost my train of thought here. X plus 3 over x plus 1 x plus 3. So let's find our whole. So, of course, that being positive to 3, x plus 3. And we know when we solve it, a whole going to be x equals, well, whole is just negative 3. All right? That's my whole, negative 3. So, my vertical asymptote is going to be, well, let's start with the domain restriction. So, my domain, which again, the number that makes the rational function undefined, is going to be d cannot equals negative 1. So, my vertical asymptote is negative 1. And then, use my rules with the horizontal asymptote, and then I do a little bit of work in the denominator to get 4x plus 4 over x minus 2. Again, not really necessary, but when I look at these right here, again, the the variables with the exponents, so they have the exponent of 1, so guess what? I just divide, and that represents 1 over 4. So my horizontal asymptote is going to be 1 over 4. That is how you solve for this problem. And yes, I am going to put something like that on your test. So be prepared to put in some work. All right, guys, let's get back to it. So for number 8A, personally, I'm going to skip that one because A, it's not on your test, and B, I'm just a little lazy, so I don't really want you to be too much concerned about that because it doesn't involve any of my favorite things. I want to factor the thing out and do swing method and stuff like that. So that's not there. So I don't want it. So focus on question B because you're going to definitely see something of that nature of this test. So of course, least common multiple is x plus 1, x plus 2. So on your study guide, you could just mark out 8A. I won't count that against you. So let's go ahead and do it. So 4 times x plus 2 minus 2 times x plus 1. Because again, least common multiple is x plus 1, x plus 2. So you just kind of multiply one side of x plus 1 here, x plus 2 over here, and x plus 1 over here to make those denominators the same. All right? That's what I must have. So therefore, you guys don't make those misconceptions right there. I don't want you to go through that one. All right, now we're ready. Do distributive property here. So I got 4x plus 8 minus 2x plus, well, minus 2. So when I do combine like terms, I get 2x plus 6 over x plus 1 and x plus 2. Just like I told you before, this part in the denominator, you don't have to factor that out. You could do that if you want to, just to show you got some factoring skills, show off. Foiling skills, so you can show those foiling methods. But it's not really necessary. All right? But this is what your answer should be for 8B. But again, you skipping 8A. I don't want you to do that. Oh, my favorite problems. Pride and joy. I love these problems because you have to really think outside of the box on these. Period. All right, let's go ahead and do all this. All right, let's do C, because you know C is my favorite one of them all. So, do you need swing method on that one? Not really. You can factor out the greatest common factor of 10, negative 28, 8, and 16 is just 2. So factor that out. So that's going to be 5x squared minus 14x plus 8 over 2x minus 4. All right. Okay, you keep or you change. We already kept. You reciprocate, and you get 5x squared minus 41x plus 8. Let's do this as a dot. That makes things easier for us to read. You know a dot is understood to be multiplication. All right, over 25x squared minus 25x plus 4. All right, the other two on the right hand side. Oh yeah, you're gonna do some swing method. You're gonna do swing method in all three, and yes, because you know Miss Howe loves this swing method, you're gonna be swinging all day. Swing and get an A on this test. All right, let's do what's in the numerator on the left-hand side. So you can walk the problem with me if you want to. So I'm gonna be quiet working it out while you work it with me. So I'm working it quietly while I could talk. So looking at the left-hand side numerator, my swing method. So of course multiply A times C. That gives me 40, so that should be x squared minus 14x plus 40, right? So, and of course the 2 is still outside. One of my winning numbers, when I multiply them together, gives me positive 40, but those same two negative numbers gonna give me, those same numbers gonna give me negative 14. And I pretty much just gave the answer. So you know they gotta be two negative numbers, so that's be x minus 10 x minus 4. All right. So on the left hand side, this is why I get when I factor. So I get 2. Oh, I'm not done. I gotta finish the swing method. So this is what I got so far. I'll show you because I gotta finish off my swing method too. 1 minus 4. This is what I got, and I gotta finish the swing method. So work on the left, working on the first factor form, the x minus 10. So I gotta divide that by 5. Well, negative 10 divided by 5, that's x minus 2. So I do get something like that over there. And then the second one, the x minus 4, I got to divide that by 5. 4 divided by 5. Did I get a whole number? No. So it should be 5x minus 4 in the other side. So now I can rewrite what I just did. All right. So that's what I did so far. All right. And then the bottom, the denominator, 2x minus 4. Well, I know that I have a 2 in common, so guess what? 2x minus 2. Well, I know for a fact I could cancel some stuff out on the left-hand side already. But more on that later. We gotta do other swing method things that you not like so much. Oh, right. Again, I'm doing part C. All I'm doing is part C. So if I didn't say that earlier, I'm doing part C. I'm not doing D, as you can see. Doing part C. All right. Back to this. So I'm working the numerator on the right hand side now. So in purple, I rewrote it because I flipped it, well reciprocated it. All right, let's do it. A times C in the numerator is what? 5 times 8 is what? 40. So x squared minus 41, x plus 40. All right. What are my winning numbers when I multiply them together give me positive 40, but those same two numbers have to give me negative 41 when I add them. So that's going to be x minus 40 and x minus 1. Because negative 40 times negative 1 is positive 40, but negative 40 plus negative 1 is negative 41. And they give me my terms. Now from there, I got to divide by 5, because that's what I had. All right, negative 40 divided by 5 is what? I get 8. So negative 1 divided by 5, do I get an integer? No, so swing it to the front. X minus 1. All right. We are taking care of some business, are we? Now, I can put that in the, now I can work on the right hand side now. So I get x minus 8 and 5x minus 1. That's in my numerator. All right. Now, we got to focus on the denominator. So let's go factor that and get that together. All right. So I got 25x squared doing my a times c. So 25 times 4 gives me, and that's a positive 4. Nothing's negative. It's just my bad handwriting. Maybe one day so I'll type this out. Maybe not. So 25 times 4 is 100, right? So that's x squared minus 25x plus 100. Now, what are two numbers when I multiply together gives me positive 100, but when I add those two numbers, they give me a negative 25. X minus 20, x minus 5. Make sure I got my numbers together. So negative 20 times negative 5 is a positive 100, but when I add them together, they do give me a negative 25. So negative 20 plus negative 5 is negative 25x. All right. So with that being said, I gotta see, do I get my terms? Hmm. Let's see, can I divide it by 5? Oh, divide by 25. I'm tripping. All right. So, guys, a negative 20 divided by 25. Do I get a whole number? No. But also, I know for a fact that I could simplify negative 20 over negative 25 to be in 4/5. And because I could write this out so you can know where I'm at. So I'm right here, x minus 20 over 25, because that's what I had, over x minus 5 over 25. So look, what I'm trying to do is simplify, because I know 20 and 25, they have greatest common factor of 5, so they're simplified to 4/5. And because I want to get a whole number, I can simplify that to 4/5. So this is going to be a 4, and then because that's 25, that's going to be minus 5. All right. So here, negative 5 over 25, I can simplify that as 1/5. And because 1/5, I could show it, because 1/5 is now a whole number, I could just move that 5 into 5x and leave that 1 in the numerator alone. So bam. So I think we could do some cancellation now, finally. So, ready, set, cancel. I was trying to cancel that, but it was telling me no. So 5x minus 4 could cancel with, hang on for a second. So don't worry about this at the moment, because I know I did something a little bit off was over here. So this cancels out. This cancels out. All right. The 2's cancels out. So I got x minus 8 in the numerator, but let me double check what's in the denominator. Oh, I see. Yeah, I got that backwards. So that's why. So it's supposed to be 5x, because remember, you're swinging always the denominator. The denominator's always got to be swing. So it's going to be 5x minus 4. Don't forget that. Denominator is what's swinging. The numerator stays the same. Denominator swings. So you cancel that out, and you are left with x minus 8 as your final answer. Woo! Again, that's Mr. Howard's favorite problem. I'm telling you, Howard loves him some swing method, and you're gonna be testing on that too. So you might come get to work and get to swinging like you're beating up somebody. All right, y'all. So that was C. We're gonna do D. All right. So let's do D. So factor the numerator. So I get, well, I factor the numerator, x minus 5, x plus 5. What is x minus 5, x minus 5? I'm tripping. because when you multiply -5 and -5, you get positive 25. But when you add them, -5 plus -5, you get positive 10. All right. And then here in the denominator, pull out 10. X minus 10 is what you're left with. And then times x minus 10 in the numerator. So that in the denominator of the right hand side, you could factor out 9. And then you could do 5 minus x. You could do something even better than that. You could factor out -9. Factor out -9. And then from there, you do x minus 5. I did that because that just makes things easier for me to factor out. Because guys, when we was doing it with 9, 5 minus x. Now, you could rewrite this, but it's going to come out as -x plus 5. So what I did over here, I was just like, why not just pull a negative out? You personally don't have to do with what I did, but as long as you got something out like this, that's fine. Well, actually, you have to, because that's the only way things going to cancel out the way that you need for them to be. So that's a have to situation. So do what I just did because you want this x minus 5 and you want this x minus 5 to cancel out there. Because that's the only way the x minus 5 can cancel out. And again, it's mathematically legal to do what I just did. Then x minus 10 could cancel out, x minus 10 cancel out. So 10 times -9, that's -90 over x minus 5. And that's fine right there. You could do that. So again, rearrange it to make it look like something that you can cancel out. Because again, if I was to left it like what I did here, I couldn't cancel that out. So I know everybody have a negative in common. So you always pull out a negative. All right, boys and girls. Now this is what is going to become the workout. Now, I'll be impressed to see how many people actually get this one right because I know this is a practice. Because one thing you have to be good with is your factoring. So we know the least common multiple of this is n plus 8, n plus 1. We know that. So let's go ahead and get started. So n plus 1 times n plus 5 is going to be here on the left hand side because the n plus 8 cancels out. Well, let me do this anyway so you can see what I'm talking about. All right. So this is what you should have on your paper. You should be able to have everything set up. Now, you can cancel things that look alike. So on the left hand side, I got n plus 8. So that cancels out. And then over here, the n plus 1 cancels out. All right. So when you get to this point, you should have n plus 1, n plus 5 over here equals 1 times n plus 8, n plus 1 plus 6 times n plus 8. Now, to get this problem officially solved, you're gonna have to do the following. You're gonna have to use your distributive property skills, and you're gonna have to do your formula method too to get to all that. So let's do it. So when our for first, outer, inner, last. Well, let's go over the first part. N times n is n to the power of 2. So that's the n part. Well, the first part. The first. The outer, which is n times n plus 5 plus 5n. The inner, 1n plus, times n is positive 1n, or n. 1n is the same as 1n. 1n is the same as n. All right. And then for the last part, 1 times 5 is just 5. So that's what you get on the left-hand side. All right. Right-hand side. The 1 doesn't really matter because 1 times anything is itself. So let's do it first, outer, inner, last. So n times n is n to the power of 2. N times 1 is just plus n, or 1n. However you use it, that's fine. 8 times n is plus 8n, because that's my inner part. And then my last, 8 times 1 is 8. All right. Now, let's do the last part of this. Using your distributive property, you're going to get plus 6n plus 48. All right. So we pretty much got everything set up. Now it's just combining like terms to put everything together. Now, again, this is something that you gotta make sure that your factoring skills are up to par. Most likely, I will put something like this on the test because it it incorporates the stuff that we did with the rationals, and also go back to what we did with the quadratic. So that's why I want to kind of, I'm most likely gonna put this on the test. Because again, 30 to 50% of your study guide will be on the test. So you may see this again. But make sure you got your factoring and stuff together. And again, of course, I'm looking for precision because this is a test. I'm looking for the accuracy of your skill. So make sure your factoring is on board here. All right. We got everything. We should be looking good. So let's go ahead and combine our terms over here. So let's go ahead and do that. So we should have, when we combine our terms, we should have on the right hand side, well, let's do left first. So n squared plus 5n plus 1n is 6n, because I'm combining like terms, plus 5. That is what you get on the left hand side. Now let's see about the right hand side. Combine all your like terms. So n squared is, and there's only one n squared on the right hand side, so you won't do nothing, you can't do nothing else about it. So let's combine n plus 8n. Well, that's 9n right there. All right. And then we have something with a plus 8. And then we have 6n. Again, we're going to combine those terms. So let me fix that a little bit because I got light terms here. N plus 1 n, I mean an plus 1 n is 9n plus 6n. That's going to be 15. 15n. All right, 8 plus 48. That's my other light term. That is going to be plus 56. All right. This is what you should have so far on your paper. So let me rewrite what's on the left hand side with the black color so you can see it, just in case you can't see. So n squared plus 6n plus 5 equals n squared plus 15n plus 56. All right? So this is what you should have by now. I'm not done yet. So if you need to pause for a second to catch up on what we just did so far, please pause the video and do just that. Meanwhile, I'm erasing. I wish sometimes I had more space to just work and work and work and work. I promised to buy new software so I could have that going on. Because this, of course, is not cutting it for everybody. All right. So let's go back to what we had going on. So we had n squared plus 6n plus 5 on the left hand. And then on the right hand side, we have n squared plus 15n plus 56. All right. Now, this is all about moving stuff on the left hand side and solving for n because you guys know how to do this part. So when I move a n squared to one side, guess what happens? They just cancel each other out. It doesn't matter what side you go. You could move this n square right here and make this a negative n square if you wanted to, and you put that right there. Guess what? It still cancels out, so it doesn't matter. So the n squares are canceled out because if I move one to the other side, it cancels out. So I'm left with a 6n plus 5 equals a 15n plus 56. And if you want to see how I got 56, go back to what I did beforehand to give me that 56, all right? So let's finish solving this. So you could subtract 56. It doesn't matter which way you go with it. You could go from right to left or left to right. It doesn't matter which way you go. Your answer is still going to be the same. So minus 56, that gives me a negative 51. 6n minus 51 equals 15n. And then from there, because I went to the right side, now I'm going to go to the left. Minus 6n minus 6n. And that's going to be positive 9n equals negative 51. So, of course, when you divide it, you get negative 51 over 9 equals n. But you could simplify that and you get negative 17 thirds. And that's n equals negative 17 thirds. And that is how you solve that complex problem. It's a lot, but again, you're gonna see something of this nature on your test where factoring is gonna have to you want to fall out, and that's just it. Of course, that's considered to be part of factoring, but you're gonna see something like this. All right, 9B. All right, least common multiple is 6x squared. All right, so let's do it. So if I do 6x squared on the left hand side, that cancels out. So however, 6x squared over 2x plus 7 times 6x squared over 6x squared. That cancels out too. So using your laws of exponent, you subtract those x's, and it's going to be 3x equals 1 plus 7. Subtract 7 from both sides. And you get negative 6 divided by 3x. X equals a negative 2. And that's essentially how you solve that problem. Now, however, on your test, I'll be asking you, is that a true solution to the equation? And how you do that is, you're going to take this negative 2 right here, and you're going to plug that back into the equations. So I'm going to leave that for you to do because that's easy. So every x you see, like 1 over 6x squared, that's going to be 6 times negative 2 to the power of 2, which you know, when anything's negative raised to an even power is always positive. But again, I task you of doing that yourself. But this is how you do B. All right, my people. We're pretty much at the end of this. So 9C, getting started with a problem like that. So you know your least common multiple is pretty much going to be 5x for this one. So here on the left hand side, multiply this by 5x on this left hand side. So 6 times 5x over 5x plus 1 times 5x. So let's go ahead and get this started. So on the left hand side, the x's cancel out, and that's going to be 5 equals. And then here, the 5x's cancel out plus 6. 1 times 5 is just plus 5x. So now get rid of that positive 6, so you know that to be just that. So subtract 6 on both sides. You get negative 1. All right, and you're left with 5x. So divide that, x equals negative 1, 5, negative fifth. So of course, I need for you to check to see if that's a true solution by you plugging that in to find out does it equal all of that. So that's for you to find out. So that's how you do C. Let's talk about D right quick. So we know the least common multiple, least common denominator is going to be 4b squared. So we know that. So let's go ahead and do it. So 4b squared, b plus 6 over 4b squared. And I have my way of doing this so you guys could see what's going on. Plus 3 times 2b squared times 4b squared, right, equals b plus 4 over 2b squared times 4b squared. All right, so on the left hand side, these cancel out, so that's b plus 6 plus, so here you can cancel out the b squares, and then that'd be just 3 times 2, which is 6. All right. And I'm doing part D. We did see already, so I don't want y'all to jump crazy. If you have not paid attention, please be with me because I know this is a long video, but you need the explanation to understand what's good. All right. Now, let's do what's on the left-hand side. So, the b squares cancel out, and the 2's also cancel out, so that's just b squared times 2. So when you multiply distributive property, there's going to be 2b plus 4. So that's b plus 12 equals 2b plus 4. All right. Subtract b, subtract b. So that's going to be b 12 equals b plus 4. So I'm going to make some space for us to finish working out everything. All right. I think that should be enough for us right there. We write something simple. So subtract 4 on both sides. 12 minus 4 is what? 8. B equals 8. That's essentially how you do that kind of problem. All right, these problems. I'll probably put just at most one question there. I'm not going to put that many because they're so easy. So y equals k over x. You could do this one. So y is 14, right? Equals, because you hear varies inversely. So 14 equals 8. And we got to find k first. So what's 14 times 8? Y'all give me a second while y'all figure that one out. All right. All right. I'm sorry. I'm back. So 14 times 8 is 112. 112 equals k. And it said that we got to find y when x is 7. So that means that y equals 112 over 7, which gives me y equals to be 16. And that's essentially all you're doing for those kind of problems. You are multiplying, then dividing. Because those are very simplistic and very easy going, I'm not going to do the rest of them. So B, you could figure that one out on your own because all you're doing is multiplying and divide. Multiply and divide, multiply, divide. Anytime you see the word varies inversely, multiply and divide. Just what we did. All right, y'all. That's pretty much it for the for what you need. I know this is long, and I know it's been some work, but this should help you prepare for your test. So listen up. Again, 30 to 50% of these questions go be on your test. So I may do 10 questions maybe, or I may be do 20 questions. So it's gonna be in between those numbers. So I probably keywords probably gonna end up with 10. But again, 30 to 50% of the test is gonna be your study guide. The rest of the test, I guarantee you, is gonna be from what we did with the notes. It's gonna be from what we did with Kahoot. All the Kahoots I sent to you, see to it that all the Kahoots that I have sent to you over this Mardi Gras break, you have them done by Friday by noon. And yes, I am grading for accuracy. Now, the Kahoots that already been closed and passed, well, fortunately, I can't open those up. So if you didn't do them, you're just going to have to take the hit on that. And remember what I told you, if you did well, score at 80% and above, you will have an A on all assignments regard to the rational functions, and that including those Kahoots. If you still gotta do, you still have to make some type of touch to them. One thing that I will not do, however, if you haven't even got started on these Kahoots or got started on any of these homework, even if you did get 80, I'm still gonna count that against you because I need for you to have at least did them first. The only time you could be excused from that if you have a validated reason why you're absent, such as COVID related issues. All right, y'all. This has been long enough. So good luck.